Hi everyone, Mrs. Syed here. So today we're going to be talking about molar mass and conversions. So I have a question for you guys. What comes to mind when you hear the word mole? Perhaps you think about a mole that could appear on your skin or the animal. So, there are many different definitions to the word mole. In my opinion, the most important definition is the one that's chemistry related, of course. So, basically, in chemistry, a mole is just an amount. So, you know how we use the word dozen, and that means 12? In chemistry, when we use the word mole, it just means that there are 6.022 times 10 to the 23 atoms or molecules. That's an important number. Remember, it's 6.022 times 10 to the 23. That is Avogadro's number. So we're going to be talking about molar mass today, which is just the mass in 1 mole of a substance. So if you look at the periodic table, let's say you look up the molar mass of carbon, you'll see that it's written 12 grams per mole. And all that means is that for every 1 mole of carbon, or 6.022 times 10 to the 23 atoms, there is 12 grams. So if you kind of think about it, it'd be impossible to get the weight of just one atom of carbon because it's so small. That's why we are using the unit mole. So 6.022 times 10 to the 23 is such a big number. That's enough atoms to be able to get the weight of an element. So for carbon, it'd be 12 grams per mole. We're going to be learning how to calculate the molar mass of an entire compound. So the equation for that, or the formula for that, is written in the last bullet. So if you want to just pause the video and write it down. The formula is just the mass of the first element in the compound times the number of atoms of that element in the compound, plus the mass of the second element times the number of atoms of the second element, and you keep doing that for however many elements are in that compound. I'm about to show you an example problem, so you'll hopefully get what I'm trying to say. All right, so here's an example problem to calculate molar mass. So for our example, we have to find the molar mass of H2O, or water. So step one, I'm going to list out all of the atoms that are in my compound, okay? My compound is H2O. So I know I have hydrogen and I have oxygen. I'm also going to include the subscripts because that indicates how many atoms of that element are in my compound. So first I'm going to calculate hydrogen. I'm going to find the molar mass of hydrogen using my periodic table. So if I do that, I'll see that the molar mass of hydrogen is 1.01 grams per mole. And I'm going to multiply that by the number of atoms of hydrogen that are in my compound, which are 2. Okay, then I'm going to do the same thing for oxygen. I'm going to look up the molar mass of oxygen on my periodic table, which is 16.0 grams per mole. And then I'm going to multiply that by 1 because I don't have a subscript. So every time there isn't a subscript, I know there's just 1. So now I'm going to do the math across for each one. So for hydrogen, 1.01 times 2 is 2.02 grams per mole. For oxygen, it's going to be the same thing because it's just times 1. Okay, so that's how many grams of hydrogen I have and how many grams of oxygen I have, but I need the total grams of my compound. So the last step is to just add those two numbers together. And when you add them together, you get 18.02 grams per mole. Okay, so that's the molar mass for water. All right, so now we're moving to the second part of our lesson, which is conversions, right? So we're going to be converting moles to grams. And you guys are already experts at conversions because we did it in the beginning of the year. So it's not going to be such a foreign concept. The only difference is now we're converting moles instead of, like, let's say metric units. So this example problem, how many moles are in 15 grams of lithium? So just like any other conversion problem that we've done, we're gonna set up our conversion with that little sideways T. Remember that? See, I told you it's gonna come back and it's gonna be useful, right? So on the outside of the T, I'm going to put what the problem gives me. The problem is asking me to convert 15 grams of lithium into moles. So on the outside, I'm gonna write 15 grams, right? So for any conversion to work, I want my units to cancel out. So my unit on the outside is grams, so I know that my unit on the bottom needs to be grams. And then the unit that goes on top is the unit I'm solving for. So I'm solving for moles, so I'm gonna put that on top. Okay, the unit for moles is MOL. So now all that's left is to fill in the conversion factor. So if I read the problem, it's asking how many moles are in 15 grams of lithium. So I just need to look up the molar mass of lithium using my periodic table. So if you look that up on your periodic table, the molar mass of lithium is 6.94 grams per mole. So all I have to do is just fill that into my conversion. So for every 1 mole of lithium, I have 6.94 grams. Now all that's left to do is the math, and we know we multiply across and divide on the bottom. So 15 times 1 is 15, divided by 6.94 is 2.2. My units cancel out, and I'm left with moles, which is what I want. So there are 2.2 moles of lithium in 15 grams. All right, so this is another example for a conversion problem. This one is a little more complicated, but it's just because there's one extra step, but I know you guys are gonna be able to do it. So the problem is, how many grams are in 4.5 moles of sodium fluoride? So the only difference so far with this example is now we're converting from moles to grams. The last problem, we did the other way around. We converted grams to moles. So just like any other conversion problem, I'm gonna set up my sideways T. I'm gonna put what's given on the outside. So 4.5 moles. And I know I want my units to match from the bottom so they can cancel out. So I know mole now is gonna go on the bottom and grams is gonna go on top. Now all that's left is to figure out what my conversion factor is, right? So we're talking about sodium fluoride. So this is the extra step that I was talking about. We just have to take a moment to calculate the molar mass of sodium fluoride, right? Which is what we learned how to do in the very beginning of this video. So I'm gonna list all the atoms in my compound, which is sodium and fluoride. Then I'm gonna look up the molar mass of the element on my periodic table. So the molar mass of sodium is 22.99 grams per mole. And I'm gonna multiply that by 1 because there's no subscript, so I know there's just 1. And then I'm gonna look up the molar mass of fluorine, which is 19 grams per mole. And I'm also going to multiply that by 1 because there is no subscript. So we know that if we're multiplying it by 1, it's going to be the same number. So I just have to add these two numbers together now. So if you add them together, just punch it into your calculator. You should get 41.99 grams per mole. So I'm just gonna bubble that. Now I have my conversion factor. So for every 1 mole of sodium fluoride, I have 41.99 grams. So I'm just gonna fill that in. For every 1 mole, I have 41.99 grams. And now I just do my math. So I multiply across and I divide on the bottom. So 4.5 times 41.99 is a pretty complicated number. I'm running out of space, so I'm going to write it over here. It's 188
0.955, which I'm just gonna round to 190, okay? Just for the sake of this problem. And I can't forget my unit, so I know the moles cancel out and I'm left with grams, which is what I want. Right, so I have 190 grams of sodium fluoride and 4.5 moles. So the only difference with this problem is we just had to take the extra step to figure out the molar mass of that compound. And then everything else is the same.
Alright, so that's it for this video. Just a disclaimer, for the last two example problems, I had the headers reversed. It's not a major detail, but just wanted to let you guys know. But yeah, I miss you guys all so much. We'll be back at school hopefully before we know it, but until then, stay safe, everyone.